cloud. Good afternoon, everyone, and welcome to the bi-weekly Hamside Telecon. This is Nathaniel, W2NAF. And this past week, it's been a busy week. I've been working on continuing to write my geophysical research letters manuscript on the LSTID that I've seen in the RBN and WSPR and PSK reporter data. So I'm making progress on it. I'm not nearly as fast of a writer as I would like to be, but I am definitely making progress. Let's see. I guess the other thing many of you know, since most of you are on the Monday night telecon, we probably cannot have the Hamside workshop in Scranton this coming year. So I'm working with Bill Engelke to see if we can have it possibly in Huntsville, Alabama. So we are working on that. All right. So let's see. Mike and Naruda, how about you?
I'm Michael Naruda, Alpha Alpha 8 Kilo. Greetings to everyone listening. Back to you, Nathaniel.
Thanks a lot, Mike. Let's see, Dev, how about you?
Hello, everyone. I'm Dev Joshi, KC3PVE. I have a news to share, perhaps. So I am finally moving out of Scranton. I think I'm going to University of Iowa around January, coming January. So that's the new news with me, I think.
Thank you very much.
Changing schools?
Yeah, I'll be working with Professor. My current contract here at Scranton was for 2 years. That was coming to an end. So I was applying for positions, and I applied, and I found a position.
Congratulations.
Yeah. Thank you.
So yes, we will miss you, Dev. But we
I might come to the telecons.
You're more than welcome to.
Yeah.
We'd be glad to have you continue to participate.
Yeah.
So that'd be really good. And then hopefully we'll have you for the Hamside workshop too, to present on your results in March. So great. Thank you. Steve Serwin.
Hi. Well, I've been working on this AGU paper, getting it down to 6 slides or something like that, and that's doing pretty well. I got Christina's overleaf copy this morning. I'll be reviewing that this week and getting her some comments. And I dug out an old circuit for a multiplier circuit. WWV is going to put those test waveforms on the air, and I'm going to copy the ones I had in the test file and see if I can do something with them. And that's about it. We've got our first taste of fall. It's not 90 degrees and humid anymore. Cold front came through. It's windy and in the 70s. Very much more pleasant.
That sounds so much better. Have you been flying at all?
I have. And I'm planning on flying tomorrow. And then a week from tomorrow, I'm going to fly to Fredericksburg and go tour the Nimitz Museum.
Oh, wow.
Hey, little girl.
Fredericksburg, Maryland?
Texas.
Fredericksburg, Texas. That sounds great. All right, Steve. Perfect. Okay, Gary, go ahead.
Yeah, good afternoon. Gary, AF8A here from east of Cleveland. This week I got my Tapper WSPR board plugged into my Raspberry Pi. I got that up and running, at least on a dummy load. Working on an antenna coil now, so I can at least put something up to get going on 30 meters. And then I got to read part 97, the rules and unattended operation and beacons and all that. So once I understand that, hopefully I'll be out there generating some WSPR data. Back to net.
Thank you very much, Gary. That's fantastic. Bill, AB4EJ.
Well, I sent you some stuff earlier today, Nathaniel. You'll see in your email a couple things. Working a bit on the spot data and trying to come up with ways of detecting TIDs. So I had a question for you, Nathaniel. Do we have a collection of the images that Diego created, both showing TIDs and then other ones that show no TID? Because I have to train the model. I want to try doing a TensorFlow model. I have to have a collection of yay or nay, a collection of there's no TID there and a collection of, there's a TID there.
I have the database that has that coded that way, 01, and I can send that to you.
You have all the images?
I don't have images. I just have observations, a CSV file.
I do have the images. They are available on Google Drive or Microsoft OneDrive. I can send you the link to them. They are not categorized as, TID or not, just in the images. They're all just in chronological order. But if you pair that, they do have the dates in the file names, and then we have all of the date information in Diego's spreadsheet. So between the two things, you could sort them.
Yes, that I do need that. So if you would put the link in the chat or email it to me or something, I can make some progress there. And Bob, I guess I need to, or is that CSV file that you mentioned, is it also included in the Google Drive?
I don't
Well,
know.
yeah, probably not, because Diego created it for me, but I can send that to you momentarily here.
That would be helpful.
Yeah, I'd be curious to see, we can do some interesting stuff here and see whatever your algorithm does and see what the, positive predicted value is and negative predictive value, and, what the correspondence is between your algorithm's insight into TID versus the way Diego classified it.
Well, when Diego was classifying it, I was under the impression he was doing it by manual inspection.
Yeah, yep.
Okay. So that's going to be helpful. So yeah, I tried a few numerical approaches, and I feel like I'm getting kind of up a stump a little bit on that. So I'm going to take a look and see now how many images are over what time frame, Nathaniel? Do we have a year's worth, 2 years worth? What do you know?
Yeah, so I just put the link in the chat. There are 2 years worth of images there. However, they are, I believe Diego has only categorized 1 year's worth of them.
Yeah,
He's
2017.
Yep.
Okay. But that's a huge help.
Mm-hmm.
With this amount of data, I can at least do a preliminary training. You should really have at least 10,000 images to do a proper training, but we'll have to work with what we have.
Yes, so that will be a start. And what we can do is we'll keep going around with the list right now, and then once we get to the general discussion, we can come back to this. And if you want to show some of the things you've been trying to do with getting a number, we can try and brainstorm some other approaches or something like that.
I can show you what I've got so far.
Okay, that sounds great. We'll come back to that during the general discussion. Wonderful. All right, so let's go to Tom McDermott, N5EG.
Well, good afternoon to everyone. Been working on FPGA code and still slugging away at that. Back to the group.
Great. Is it coming along better now? Or is it still?
It is. I still have random crashes every other time I start it.
Mhm.
And I think there's an initialization problem in one of the device drivers, but I haven't dug down into the device drivers to try and figure out what's going on.
Mhm.
So one of these days, that'll move up the list after I finish some of the other coding.
That sounds really good. All right, well, keep slugging away. Great. So then KF6FLJ, go ahead. Vilavec.
He's on mute.
You are muted.
Haven't got a microphone.
plugged in. Well, it is nice to see you. Thank you very much for joining today. And if you'd like to put any, welcome to your first time here. So as you can see, the way we run this telecon, there's a couple different formats. One is an informal format, which is more of what we're doing today, just seeing how people are coming along. And then every once in a while, we also have more formal presentations on different topics in atmospheric and radio physics. So today is just more of an informal day and working on different problems for today. So welcome to the group. All right, David, N1HAC.
Hello, mobile today. Just thought I'd check in, working on Arctic and Antarctic projects and everything in between. I had some ideas for the WWV propagation signals that are upcoming. So lots of exciting stuff going on.
Great. What types of ideas for the WWV projects?
Well, I was talking to Christina this morning about this, but we may be able to repurpose some of our receivers to pick that up. And I noticed that the project is focusing on Kiwis, but we don't have any Kiwis, but we have a bunch of other SDRs. So if that project could be made generic, that would be helpful.
That sounds really good. And for people who don't know what David is talking about, there's a group of people led by Christina working with the WWV team, like the people from WWV, to actually send out a signal on the WWV frequency specifically for getting more information than just a regular carrier. Actually, Steve Serwin, do you have more information on that?
Unmute.
I'm working on it. You can only press that mouse button so many times till you get the right one. Actually, Nathaniel, I'm not part of that working group.
Okay, I thought you were.
No, if you look at the roster that Christina published, but I do have some waveforms in there, and I do intend to finish what I started and do the processing on those particular waveforms as soon as I copy, and I'm going to copy some on the air, and I intend to use just I wanted to see something that could be done with just regular ham radio receivers, so it opened up to everybody using the equipment that they got. So anyway, I haven't been involved with where it's going and now.
Okay. Well, I think there will be an.
Basically, what they wanted to do was back off on actually doing something right now for science and just characterize their transmitters.
That's correct.
Yeah.
And there is a news article about that at that website that I just posted. And they are working up there should be a new announcement coming up soon. I think they're planning on doing their first broadcast on November 15th. I think that's what Christina said this morning.
Yeah, she was saying that the announcement will start November 1st and the actual broadcast November 15th.
How long is it going to run?
Let's see. It will run, I'm not sure. But if you have a Kiwi SDR, and you want to be a part of this, you can fill out that survey link that I just put in the chat.
I don't have a Kiwi SDR, but do you know what the dates and times are that they're going to be on the air?
No, I don't know exactly. I think they're planning on starting it on November 15th. And I think it happens on the 8th minute after the hour and the 48th minute after the hour.
8 and 48. Every hour?
I think so. But I think more information will be. They're going to make the formal announcement on November 1st.
And are they going to repeat okay. I'll just wait. But are they going to repeat the waveform for the entire 45 seconds or whatever it is that they've got?
I don't think so. I think there's a certain time slot where you're allowed, where they have like a standard time slot where you can drop in different audio announcements. So I think we're taking up that standard time slot. But I think we'll have to wait for the actual announcement on November 1st to get all of those details.
Yeah, okay. They're going to announce it on the air?
They'll probably announce it on, there might be an announcement on the air, but I'm sure there will also be an announcement on the HamSci list, and maybe they'll send it out to the ARRL as well.
Yeah, I presume it will be on the air, because that's what they do. They broadcast the announcements ahead of time of changes that they're going to make.
So thank you, David. And then let's see, Jules, K2KGJ.
Yeah, I just finished up some yard work and thought I'd come in quickly and see what was happening in the group. Just monitoring today. Thanks.
Thank you. And how are things going with the new magnetometer?
Good. So far, again, Scotty's boards are working very well.
Excellent. And hopefully I will get mine in the ground and running relatively soon. I think it's still a couple weeks away.
Yeah, I do have a fast sampler for a single axis that will, there's actually fast enough to meet 60 hertz Nyquist requirements. So you can see if, if anybody thinks they have 60 hertz interference, this will point it out.
Okay, that's great. When you say a fast sampler, is that a different piece of hardware than?
No, it's using just a single axis with a 200 cycle time, which means I can get down to a 3 millisecond per sample time period, which is then, it's above Nyquist frequency for 60 hertz, and it gives you quite a nice picture.
Okay, that sounds great. All right.
Resolution is only 13.5 nanoteslas, but typically the interference, like Dave Walk, for example, has been getting, is looking at 300 and 400 nanotesla interference. So this thing will easily give you a nice picture of that.
Okay. That's good. Great. Did we get through everyone on the list?
No,
No? Who did I miss?
me.
Bob. Bob, what's going on? WKTY.
So besides running around trying to find doctors, spent a couple of days working with Diego, crunching his TID numbers, and have cranked through some preliminary analyses, and probably at some point need to sit down with some folks who want to focus on it and get some direction about what things to include, not to include in a model, how to include them, and move forward with that. There's the one obvious thing is the relationship with, I think I sent that graph to you very quickly, Nathaniel, that AE is the electron density. Is that correct? AE is definitely
overall electrojet index.
Yeah, right. That's definitely got a relationship there. Not much, but it's with sufficient observations, you can certainly see something.
Yeah, we looked at your plots at the Tuesday morning meeting. And so we went through all of them. And so we saw AE had a relationship. And it also looked like would you say the UNH, that neutral winds? Do you think
that's kind of a weird, it's kind of a weird distribution. And again, the question I have is, are we looking at things individually? Are we looking at things jointly? Are we looking at things in a temporal sequence? Do we need to consider lag relationships, interactions? There's a whole bunch of possibilities, and I don't really have your background or anybody else's background here for that matter to know what to throw into model. Now I can throw everything in and see, like I said, usually say torture the data, but it's usually a little more robust and more easily written up if we proceed in a principled fashion, but we may not be able to.
Okay. Well, I have some thoughts on that. And
Okay.
so one thought is I am interested if the AE and the UNH are jointly have a connection. So if you need both that neutral wind to be in the eastward direction and have a high AE.
Go ahead. I'm just making notes here.
And the other thing I want to show you is I'm working on this paper right now I'm looking at just this one traveling ionospheric disturbance. But up here, this is a parameter that's very similar to AE. It's basically showing the same thing. And it's showing up about 3 hours before we're starting to see the TIDs here.
A lead correlation. I've never had one of those.
Well, because you expect the AE to cause the forcing, and then it takes time for that forcing to propagate down to where we see the observations in the United States area. Because this is happening in the auroral zone.
Mm-hmm.
And it's launching a wave that then needs to travel from the auroral zone down to the mid-latitude region.
Well, that gives me something to play with.
So I would expect.
Are any of the, obviously, I mean, the theory behind this latter AE and the propagation, the temporal lead lag, if you will, is easy enough to understand. The AE and UNH, what is the theory? Is there a theory there? What is the?
So my thought, if you have, you can have the winds, if the winds are blowing in a certain direction, that can prevent the waves from propagating from lower levels of the ionosphere up to higher levels of the ionosphere. So the thought is if the winds are going in one direction at a particular speed, it will allow the TIDs to go through. And if it's going in a different direction, the waves may still exist at lower altitudes, but they may not propagate up to the region where they affect the ionosphere.
Okay. I'll have to think about how that might appear in a model, but that's okay.
But I thought, let's see, I think I have what you sent on Monday, Tuesday. That was, I have to remember what, wait, no, this one, and then that one, and then that one, and then that one, that one. Actually, no. It's not there. There's off. Appropriate. Okay, I think I found it. Nope, wrong one. So this was the AE distribution you were talking about, right?
Right. Yeah.
So this is definitely showing that this distribution is different from this one.
Yeah, and in a model, it says that as AE increases, the probability of a TID also increases.
Right.
Not by much, and there's a lot of overlap.
And then what about this one?
I forget. It would appear that, again, the same thing, but I don't know that there's sufficient. It's suggestive, but I don't remember if I can actually run that very quickly here. I don't want to keep us from moving on to something else while I run this, but it's just that it's so kind of weird with those values there. So distinct and isolated, and then this group that has a rather large peak in it. It's just strange, is all I'm saying. Where are we? Okay, here we are. Load it.
That's why I'm wondering if this jointly with AE gives us anything more conclusive.
That will take a little while longer to explore. But let me just see. So in that model, yeah, it's just barely significant. And let's see what and it is a positive relationship, so they could be, we'll dig into it deeper. Let me see, that runs from -2 margins. And this so the problem is the distributions don't overlap, so we got to be careful when we do 2 to 2 by 4. Let's see what it looks like. Yeah, it's increasing from about, the probability is very low. At -2, the probability would be less than 1%, and then it goes on up into, well, it goes from 0.007% to 0.008%. So the variability.
That's not a very big change.
No, it's extremely small. What it's saying is, and the confidence intervals are extremely wide. What it's saying is that there's so much variability in that particular measure that it doesn't do a really good job predicting anything. So you're going from slightly less than 1% to slightly less than 1% probability. So now, is it a moderator or mediator with the AE? Don't know, but my knee-jerk reaction is that it suggests that there's a measurement problem here in whatever this particular measure is. Now, that could also have to do with the fact that, I forget what the time intervals are on each one of these things. Your TIDs, Diego classified them, I think, on an hourly basis, but some of these things may be only daily measures and consequently you don't really have the resolution to figure out what's going on.
Mhm. So okay. So basically we need to do a little bit more digging, but this is not nearly that suggestive.
And no, not in my book.
Okay.
You guys are the physicist, and maybe this is,
Yeah.
run to the journal with it, but I don't know.
Yeah. No, I
It's
think we
nothing
need
I
to
would
do-
run to a journal with in my field, but
Yeah, I think we should work on this a bit more. So
let me
okay.
just email that to you, and so you can edit. Maybe you can share it on screen or something there. There you go.
Okay.
And the other big event is I will be going to see Dune tomorrow.
To see Dune.
Yes. Not
What's
too many,
Dune?
not many science fiction fans here.
I'd go if I had time.
But didn't that come out like 30 years ago or something like that?
Yeah, this is the
Isn't
remake.
that a video game?
Remake.
It's well, this is the third remake of the movie,
Okay,
or rather the second remake. There was an original movie, a remake of that, and this is a remake of that.
so it's Old Spice and New Spice?
Very good.
That's a good one.
See, I have not gotten your email yet, Bob.
No, it's because I'm on Microsoft Outlook.
I'm
Let's
on
see.
Microsoft Outlook too.
It hasn't gotten out of my outbox yet.
Okay. Well, while we're waiting for that, Bill, do you want to talk about you're trying to figure these things out?
Yeah, I can show. This is really raw. I mean, it's still a bunch of spreadsheets with plots on them, but I'll tell you what I've been doing. But I've got a question for you, Nathaniel. I've managed to download the data from 2016 and 2017.
Mm-hmm.
Is there corresponding ionoson data so that I can, if I see something that looks like a TID in one of these plots of Diego's, if I can look at the corresponding data on ionoson to see if it looks like there's wave structures there as well?
I would look in the SuperDARN data. And that's what I'm doing in my paper over here too, which I've shown. So here is the ham radio observation. And here's the Blackstone SuperDARN radar that's looking northwest. And you can see the same structure in the SuperDARN data here.
Now, is this data publicly accessible, or I can just go somewhere and download it?
Yes, you can go to vt.superdarn.org and you can go to SD data plot tools. You can go to range time plot and then you can choose Northern Hemisphere Blackstone. I did beam 13.
You're going a little bit fast there. You said SD data plot pool?
Tools right here.
Pools. Oh, tools.
SD. And then I chose the one that said range time plot.
Okay. I think that gets me what I need. I can vector into it.
Well, then I picked Northern Hemisphere. I've got the Blackstone radar right here.
Uh-huh.
I chose beam 13. and then you can fill in the time. And this is showing 24 hours worth of data. And you can probably leave these values alone. And slant range is probably okay too. And you actually want the ground scatter. So that's what you're most interested in. And then you hit plot. And then you wait a little bit of time.
Yeah.
There. And so there you can see the range move out and move in.
Okay, very good. Very good. That helps a lot.
And if the Blackstone radar is not available, you can check, say, the Fort Hays East radar. That's in Kansas. And so that's just looking the other direction.
Which one is that again? Fort Hays East. Okay.
Yeah, there's Fort Hays East, which looks in the eastward direction, and Fort Hays West, that looks in the westward direction.
Okay. All right, let me see if I can pull up. Going to manage expectations on this. This is, I mean, this represents work I've done over the course of the past couple of days, mixed in with meal planning and budgets for the ham sci workshop. Let me get those out of there. All right, so
All you need is beer.
you know,
That's it.
yeah, that's a start anyway. Today's my birthday.
And not cheap beer either, the good stuff.
Yeah, the $5 glass stuff. Today's my birthday, so I'm gonna go downtown. We got a beer thing.
Happy
going,
birthday.
and they are 70 years old, the big 7-0.
QHB.
Pardon?
Is it QHB, right? Happy birthday.
Oh, is that okay? There's a Q signal for that? Okay. All right, so share. All right, what I did here was, all right, how to, all right, I wrote a program to take the PSK spot data from November 3rd, and I start out using the whole day. Let me see if I can find I didn't plan on making a presentation here, so I don't know where everything is. Anyway, I've got the spot data, and I go through it, and it's been geolocated, and we have for each spot the lat long of the center point, the lat long of the sending and receiving stations, and the distance calculated between the stations, which gives you the approximate lat long of the center point. And that's, so what I'm doing is I'm working with spot distances, thinking that spot distances get modulated along with the TID. So
Right.
I filtered out, for this purposes of this study, filter out, unless the sending and receiving station as well as a spot are both with or all three within North America, I filter it out. Then I count in each, I've tried it with several different time frames, with over 2 minutes, 5 minutes, 10 minutes, 15 minutes. I count in each time interval the number. First, I get all of the spots and I average the distances. So that's what this is. This is how average spot distance modulates over. Now, this is the whole day. That one analysis of Diego's is just, oh, this thing doesn't work very well. I use a thing called Evernote, and it's got a bug. It's a little buggy, but anyway. So this part of the chart here, that's all noisy. That is when 20 meters is essentially closed. When it's dark in North America, and you do see a few weird long distance QSOs. First, I think this may be one that includes spots where the sending and receiving station are not necessarily constrained to North America. So what you have is, no, it has to be, because you have some spots that go into the 10,000 miles. One of the things I ran into is that you can have a spot where, for example, the sending station is in South Africa and the receiving station is in central Mongolia or somewhere, and the center point of the spot is in North America. So you get a 13,000 kilometer spot right in the middle of the night or something, and that doesn't really represent any.
What I did, Bill, was in all the plots I've been showing, I've only used data that has a distance between the transmitter and receiver of less than 3,000 kilometers.
Well, that's, yeah, I mean, that's what we're looking at here. See, this is kilometers here, average kilometer for this, and so this is the noisy part. When you do have a lot of noise, but if you look at the number of spots, the number of spots is very small, whereas out in here you got 50 to 100 spots, or sometimes 1,000 in every 5-minute interval, where you got all this noise. It's just very few spots, and so it jumps all around and it's noisy. So I was trying to compare, see if I can get Evernote to run again. Ever loving Evernote. You have to excuse me, I'm not really prepared to see if I can get Evernote running again, where I can bring up that chart. Okay. This. All right, you see Diego's chart there?
Yeah, that's my figure.
Right. That's with it's got the two, comparing the SuperDARN. So this is between 1200 UT, and it's just basically the part of the day when 20 meters is open. And see, it won't let me minimize this. Evernote just went nuts all of a sudden. It won't let me drag it, and won't let me do anything with it. It's just, all I can do is close it. But anyway, that's the second half of this. So you do see a bit of a gentle curve, some kind of a curvature here that suggests maybe it doesn't line up totally with the TID data.
You know what I see there, the dip I see between 218 and 274, that kind of looks like the belly of the major spots where you get into the midday, but that doesn't really match the TID structure.
Yeah, right. So what this is telling me is that going through and using the average spot distances is not sophisticated enough technique to discriminate what we're looking for here.
Yeah.
I did try.
And that was my experience so far too, because I tried doing the same sort of thing.
Yeah, and then I tried doing. I tried several different techniques where, okay, I tried an edge detection technique this morning don't know whether it's working right or not, because you get a curve that kind of looks like this, which doesn't really tell you anything either.
Bill,
Yeah.
you're looking at all different azimuths for the between the
Yeah.
receiving and the transmitting, and at all different latitudes. I wonder if you
within North America, yeah.
within North America, but I'm still wondering if you know, above 30, below 30, above, between 30 and 60.
But we can see, like, visually, we can see the signal when we do that.
When you do what?
So like when you throw everything together, we're visually able to see the signal.
Yeah, I see. I get your point.
So like if Bill brings up that figure, my figure again, like you can see it.
Well, here's another example of it, where you see this right there. I mean, you do see, and okay, here's an example where where it does appear as though there is such a signal, and not, but there looks like there's something. Not there, no there, not there. So
it's very tough.
But it's possible.
But that thing that you're seeing could be for some particular subset of the data. So whatever's causing, it's not uniformly distributed across. It could be, but the way it seems to be happening is it suggests to me that when you see that dip or that concave structure, or convex structure, it may be happening in some portion of the data, and consequently you see it in the overall graphs. But when you put it when you calculate the statistics, it gets averaged out.
Yes, right.
And the question is, okay, so in what portion of the data is it actually occurring?
Yes, and
that's only a theory. That's only a theory of mine.
Yeah, I tried doing an edge detection where I'm trying to find where it goes from few. Well, I take a 5-minute period and I break this distance here up into 200 bins, and then I count the number of spots in each bin of distance, and then I look for the largest change bin to bin, which indicates an edge, working up from the bottom. So you find the edge, and that produces something like this. Which one is it? Anyway, it produces something that it doesn't tell you very much either. So sorry, I don't really have this organized in such a way to really show anything. But anyway, so another option that I'm looking at, which is why I asked for the whole data set, is I can train a TensorFlow image recognizer to look for images that have the structure. That is interesting, and I'm going to look through them, and I need to look through the SuperDARN data at the same time to indicate whether, if I see a structure here, if I don't see it reflected also in the SuperDARN data, I've got to be suspicious of it. But I don't know. See, you can even see a little bit of a shape there, but
yeah. Would it help to do any, like, run a median filter on the data first, where it would get rid of some of that salt and pepper noise?
Well, that would, what I've got here is just what I downloaded. I don't have the software tools easily at hand to clip out part of this image and then do image processing on it.
we can get you the scripts that will generate those. Let me show you what I'm talking about, because they actually have it implemented on the SuperDARN website. I'm just trying this, but so you see all this like speckled stuff in here? If you click this apply median filter, let's see what happens. I think a lot of the speckled stuff will go away. And this is a spatial, well, I guess it's both space and time median filter, because I think they're doing the filtering in both range and time. You can almost hear the computer crunching. Yeah, look at that.
What do you call it? A median filter?
Yeah, it's this median filter that they have.
Median filter. Mm-hmm.
Yeah. But there's a certain way they do it, and they apply it across. But you see how it got rid of all those speckles? If I start this at 12, see if I can do this again with both the median filter and not. Because what we have, like, there's a lot of noise in here. It looks like it took out some of the, but you know what? But in doing that, it looks like it kind of took out some of what we're looking for. Because now I don't see these big humps in here the way I did before.
There's a lot of processing techniques that result in loss of detail.
Yeah. Because the other thing I was wondering if it would work would be as if we just made like the assumption, which, I mean, this is kind of what the edge detection does, but basically just looking at the range between, say, 500 and 1500 and not looking at this stuff up here. If you're doing the edge detection, you're kind of going for that. The other algorithm I wondered that I used in my third figure, this figure, I used the contour F function, and I really just cranked up the contrast. So I squished the color bar and I used contour F to calculate contours. And that kind of pulls out, still not perfect. It's really tough.
Well, let me suggest this, because the way image recognition works is it's going to examine it quite in a similar way that you would do with the human eye.
Right.
So all of that discrimination that you're looking at doing with those various kinds of filters are kind of going to happen automatically.
Right.
So it would probably make the most sense for me to use Diego's image processing software and then get just the images, because the stuff that's on the Google Drive is it's a composite image that has, you know, it's got the SIM-H and it's got the radio spots on the map and various other things. And whereas we're really wanting to hone in on the two spectral displays, in other words, range versus time, those split displays. I think what I really need to do is have a program that just outputs those two images and then work with those images, and also remove the dotted line for the purposes of this analysis.
Yeah. Yeah,
And
all of that
then-
can be done.
I was reading also there's some new research in getting convolutional neural nets to tell you how they are reaching their conclusions, so that you can see what it is about your data that's driving the results. The criticism against a lot of convolutional neural nets is that it acts like a black box. It gives you a determination of what it thinks is there and a confidence level, but you don't know what about the data is triggering it to say that. And when you have multiple dimensions, you know, you get a lot of non-linear relationships can occur. So anyway.
Yeah, here, this is good, Bill.
Okay.
Look what so I had the wrong radar up before. So it was interesting. The Fort Hayes radar did not see these big LSTIDs, but the Blackstone radar did. Here, this is before the median filter, and this is after the median filter. So that actually looks like it's a lot easier to pull off that structure there.
Yeah.
So, because I think if we did implement the same sort of median filter, what we might get, it might clear up a lot of this stuff that's just noise. So that is something we could potentially implement.
Yes. Now, whether that's something that you Yeah, you know, thinking about this, I'm not sure that is going to contribute anything when it comes to interacting with image recognition.
Mm-hmm.
Because a lot of that finer detail is not what the system really looks for. Although,
but if we didn't want to use, if we weren't using the image recognition, this
Oh.
might help us to pull out a cleaner line. Like if you were doing the edge detection technique and you ran this median filter first, that might help.
Yeah.
Well, it's past 4 o'clock, so maybe we should call it for today.
Yeah.
He hears some beer calling him.
No, that's a couple hours from now. I'm not anxious to leave to go to that right now, but looking at preset filters, I'm looking to see if I can. There are online image filtering packages that will saturation. Yeah. So many things here. It's going to take a while to look through it all. Now, this is mostly for processing photographs as opposed to something like this, which is an image of data. But anyway, I'm going to work with, if I can get a hold of the software that generates the image, I can extract just what piece of it that I need to generate these images, and then I can create a library of training images, training and verification images that we can use for doing the image recognition.
Yeah, that sounds good. So I think the software that does it, it's my library. It's on GitHub, but I think Diego has the script that takes that and does the for loop and generates all of those in succession. So maybe you can email Diego and see if we can get him to give that to you.
Okay.
If in preparation for that though, you can try let's see. There's the library that makes all of these plots. So you can see if you can get that up and running. It's just with the default settings, you don't see the TIDs.
Okay, I'll have a look at it. All right, well, have a look and see what we can figure out.
All right, Bill.
Hey,
Thank you
Nathaniel.
very much. Yes.
I just got an email from AGU about the early bird registration. We still have, even though these are 5-minute things and virtual, you still got to do that, right?
Yes, actually, let me send Liz McDonald an email because I think she was trying to get a way to get you registered for free. So let me see if I can get in touch with her about that.
Oh, okay. Well, this early bird thing, which I guess comes with a discount, not that big of a discount is what you're talking about, obviously, but
Yeah.
expires.
Let me I'll send Liz McDonald an email this evening, and we'll try to get you registered for free.
Yeah, I got the same early bird notice. Yep.
Okay, and so so Jules needs the same thing.
Could you please repeat what conference this is for?
The American Geophysical Union conference.
Ah, okay, thank you.
Sure. Okay. I'm bringing up my email. Citizen science volunteers. Why is that not? Okay. I will get back to you soon.
Okay.
Okay. Thanks. All right, everyone. I hope you have a great day. I will talk to you soon.
Okay.
And happy birthday again to Bill.
Yeah, happy birthday, Bill. Congratulations.
Happy birthday. Take
Thank
care,
you.
everybody. Stay safe.
Thanks.
That'd be great.
Whippersnapper.
Bye. 7-3.